So again, for you guys attending today's webinar, you're going to be entered for a chance to win a laptop. Okay, so this is the laptop that we're going to be giving away, and the winner will be announced tomorrow. Okay, so now I'm just going to hand it over to Paul, and he's just going to start with this presentation.
Thank you, Oscar. Good morning, everybody. So once again, my name is Paul Sagar. I'm the Vice President of Product Management for the CAD products at PTC. So I have overall responsibility for Creo amongst the other CAD products we have in our suite. It's my great pleasure today to present to you Creo 4.0. Creo 4 really sees us focus on providing solutions to address the needs of the transformation in business and technology that companies are undertaking on their digital engineering journey. These are transformations from 2D-centric business practices to 3D model-based enterprise, or digital tapestry as it's sometimes referred to. We've added hundreds of new productivity improvements throughout the entire breadth of the product portfolio. We're adding capabilities to give designers tools to more easily review their designs in leveraging capabilities of augmented reality. Around design for connectivity, we're providing engineers with clear insight into how their products are being used in the field, as businesses are transforming on their journey towards smart connected products. And finally, transformations in manufacturing processes, as companies are starting to leverage emerging additive manufacturing techniques for final part production. But let's start with model-based enterprise. So more and more customers today are struggling with the burden of having a 2D-centric business practice. They're suffering from incorrect or misinterpreted 2D drawings that can lead to scrapped parts or product failures. Outside the engineering department, companies are suffering from incomplete or inconsistent information that leads to them wasting valuable time and effort in trying to track that information down. What we hear is that these companies want and need to transform their business. They want to capture and distribute richer information throughout the organization. They want to improve the quality and increase their overall productivity. To that end, in Creo 4, we see a huge investment in enabling customers to undertake this journey, an investment that closes the gap with ASME and ISO standards, that streamlines the workflows of stepping the users through the process of applying the appropriate PMI information to their 3D model, enabling companies to capture all the required rich, intelligent information directly on their 3D model. Now, working with our partners at Sigmetrics, we're also going to be offering a new GD&T Advisor extension. This will guide the user through the process of applying GD&T onto his model, significantly reducing the effort and improving overall productivity. It will educate the users on the correct use of GD&T for the appropriate geometry that you've selected. And it will also validate not only that your GD&T conforms to the appropriate standard, but also that your model is 100% geometrically constrained. All of this helping to reduce the risk of misinterpretation or misunderstanding of the information. Now, Creo 4 stands out in this sense that it's not just a solution for applying dimensions or taking your 2D practices and applying them onto your 3D model. It's not just a means of annotating your model, but it's a complete set of tools and solutions to guide, educate, and validate the information, the intelligent information is being captured correctly on your 3D model, and then providing you with tools to be able to disseminate that throughout the broader enterprise. Now, obviously, model-based enterprise isn't just about the authoring tool. It's also about communicating this information to the broader user base within the organization. With Creo 4, we've addressed this by adding support for step AP242, allowing users to export both the graphical as well as the semantic PMI information. With Creo View, we've also continued to extend the capability there, offering true WYSIWYG publishing. What you see is what you get. Exactly how it appears inside the authoring tool, inside Creo Parametric, is exactly how it will appear inside Creo View. All your combined states, your individual views will come across. You'll even have cross-highlighting between the annotations or your GD&T and the appropriate geometry on your screen. Now, many companies want and need to start this journey, but they're suffering from the problem that their business isn't quite ready to handle this information yet. Their shop floor, for example, still needs 2D drawings to enable them to produce their parts. So to this end, we've also added capability to allow the engineering department to reap the benefits of model-based design, adding this information onto their 3D model, but then allowing them to take individual 3D views and print those off on a 2D drawing. This allows the rest of the enterprise to continue to function and continue to have the necessary information that they need, while the engineering department can, in the short term, benefit from improvements in overall productivity, and gives that transformation to the business on an ongoing basis. As the rest of the enterprise is continuing to transform, the engineering department can leapfrog ahead with productivity. Now, moving on to some of the productivity improvements. Now, my team's been hard at work providing productivity enhancements throughout the entire breadth of the product portfolio. As I mentioned at the beginning, we've added hundreds of enhancements. Now, far too many for me to cover here. But I do want to just focus on a number of key enhancements. Enhancements we've made on general productivity, enhancements we've made around concept design, around simulation and manufacturing. But probably the biggest change we made in Creo 4 around productivity is the overall user model, how you interact with Creo. And we've done that by now changing to geometry-based selection. As I now pick directly on geometry on my 3D model, I'll be presented with a context-sensitive mini toolbar, providing me all the commonly used tools right at my fingertips. These are editing tools as well as creation tools, allowing me to focus purely in the graphics area where I am more focused, making me more productive. We've also introduced the notion of box selection, pervasive throughout the entire product, allowing me to more quickly select the geometry and the features and functions I want to work on. Now, because we've added all these capabilities right at your fingertips, we can now introduce also a full screen mode, allowing you to work in one giant graphics area with all your commonly used commands right at your fingertips. If at any stage you do need to access something that exists in the model tree or the ribbon, simply move your cursor up to the top and the ribbon will pop down. This significantly improves overall productivity and the general use of the tool. We validated this back in February with about 800 customers, every single one of them seeing a significant overall improvement in the time it took them to get their job done. Now, obviously, not all commands, common commands, let's say, are common to everybody. So everything you see in both the right mouse button and this mini toolbar is fully customizable. You can add any commands in there that you want, any map keys, or even any toolkit commands directly in there to really customize the tool to meet your needs. Moving on to concept design. Now, back in Creo 1, we introduced the concept of freestyle, flexible modeling capability, fully integrated into Creo Parametric, allowing you to more seamlessly and easily create free-form concept designs very quickly. What we found, though, in our customer base was there are a lot of users out there that have existing models created in other subdivisional modeling packages, such as Maya such as Modo or 3D Studio Max. And they were spending a huge amount of time reconstructing that data inside Creo to enable them to then go ahead and engineer the design. So Creo 4 sees us introduce the ability into Freestyle to bring in an OBJ file, a standard file format used to transfer information between subdivisional models. Freestyle will then completely rebuild that control mesh for you inside Freestyle and build the high-quality manufacturable surfaces for you, leaving you with a fully editable model and control mesh with the high-quality manufacturable surfaces. Now, in addition to that as well, we've also added new capabilities to allow designers to put a level of detail exactly where they want, to split the model exactly where they want and add the necessary details and creases. In this particular example, the ability to add the extra buttons to my design now becomes a breeze by allowing me to split the model and add edges and faces exactly where I want them. Now, one of the cornerstones of the Creo strategy was about expanding the set of tools available and building tools and capabilities specific to individual users, the right tool for the right user. Now, in Creo 3, the intention was also to build this out to a broader ecosystem, whether that be capabilities that are developed by PTC or capabilities that are developed with partners as well. Now, we started this journey in Creo 3 working with our partners to add capabilities such as mold simulation. And those were built as extensions to Creo Parametric. But in Creo 4, we see the realization of this vision to build apps as well. And in Creo 4, we're seeing the introduction of a new rendering app. And we're doing that by partnering with Luxion. Luxion is the producer of Keyshot, arguably the most prolific real-time rendering solution in the manufacturing segment today. This is going to give you a dedicated app marketing who want to be able to consume data from Creo, and not just Creo, but thanks to Unite technology that we introduced in Creo 3, they're going to be able to bring in data from any CAD system, apply appearances and see it render before their very eyes to generate those high quality images that they require for marketing material or websites. But in addition to that, we're also adding this capability as an extension as well. You're going to be able to do full-time, real-time ray tracing directly inside Creo Parametric. So for the engineers and designers out there that are working inside Creo Parametric, they now get the rich rendering capabilities of Keyshot with the rich control and capabilities of modifying all the different appearance types, controls over the environment that my object sits in. Even the ability to go back and tweak the overall design, make changes to my model, and then see the rendering update based upon those changes. Again, whether you're somebody in marketing who wants to make final production renderings, or you're somebody in engineering or the design department that wants to build quick imagery for product reviews, Creo 4 with embedded Keyshot is going to be your solution. Continuing on the concept design theme, we've also continued to expand upon Creo Direct. Creo Direct being our dedicated direct modeling application that's really focused on concept design use cases, allowing you to quickly take existing designs or start new designs from scratch and build upon those in a direct modeling environment with direct modeling workflows. Now here we've continued to add capability. We've added the ability to mirror components. we've also introduced Boolean operations, allowing you to cut, merge, and split different objects into different components within your dedicated direct modeling environment. Moving on to some of the engineering tools. It probably doesn't surprise anybody to know that the most commonly used command in any form of solid 3D modeler is extrude and revolve. So any changes we make there are significant productivity improvements to everybody. And Creo 4 sees us make a number of significant changes here. Firstly, giving you better access inside the graphics area to your side 2 extrude directions, but also providing you with tools to be able to combine multiple operations. So now I can say extrude up to an offset of a surface, for example. Previously, I would have had to have first created an offset surface and extruded up to that. Now I can do it all in one operation. We also introduced the ability to do a negative direction or negative extrude for the second direction. Again, this gives you more control over where your extrude starts or your revolve starts and eliminates the need to create extra construction geometry, overall improving your general modeling speed and practices. Now again, back in Creo 1, we introduced the concept of flexible modeling, giving users direct modeling type capabilities and operations inside Creo Parametric, targeted primarily at a number of different use cases, performing late-stage design changes, performing simplification of geometry for CAE analysis, or for providing you with capabilities to edit imported dumb data. But flexible modeling didn't understand sheet metal parts. It didn't understand the unique characteristics of sheet metal parts until now. So with Creo 4, we've introduced flexible modeling for sheet metal parts. Flexible modeling understands that it's sheet metal. It understands it needs to have a constant wall thickness. It understands what a corner relief is, a bend relief, a seam, a rip. And it will allow you to quickly and easily make changes to your geometry while maintaining that level of understanding and that intelligence of the part. Again, overall improving your productivity, allowing you to get your design done quicker and allowing you to make changes to your design quicker. Continuing on the flexible modeling theme as well, we've also introduced rich capability to search for particular geometry types. So now you're able to, as an example, search for all rounds in my model that are greater than 2 millimeters and less than 4 millimeters. It will then automatically identify all that geometry for you and allow you to perform operations on them. Maybe you want to edit them, maybe you want to delete them. Again, streamlining and simplifying the process of understanding my geometry and allowing me to perform operations on them. Now these searches that we create can either be stored as part of a feature definition, so they will regenerate as part of the feature definition, or they can be stored externally as a recipe file for how you want to simplify a part down. If you're wanting to go through a step of simplifying your geometry for CAE analysis, typically you're going to have certain rules around the type of geometry that you want to remove. You want to remove rounds of certain size. You want to remove certain holes of certain size or pockets. Now you can store all that information away as a search inside this recipe file that you can then retrieve back at a later stage to simplify the model down to run your analysis against. Now many of our customers out there today build large weldments, large assemblies, and the welds in this case account for a large percentage of the overall weight of the component. Consequently, we've introduced the ability now to build solid welds. Now we've had welds in Creo for a long, long time, being able to build fillet welds, butt welds, spot welds, etc. But now those welds are going to be solid geometry, so they're going to have accurate mass properties. They're going to impact the overall design process, give you a realistic understanding of what the additional weight to the component is, allowing you to define specific material properties. But not only that, these welds are fully understood by Creo Simulate, our simulation package. When you move into Creo Simulate, it will identify automatically that I've got welds. It will automatically build the connections between those welds and the components that you're trying to fasten together. So more quickly and more easily enabling you to do a full structural analysis of your full weldment assembly. Now, one of the challenges when working in assemblies is when I'm trying to mirror a subassembly. Today, what happens if I take a subassembly and I mirror it, is it takes every single component in that subassembly and it mirrors them and creates a unique new part. The problem with that is, in a lot of cases, a large percentage of the components in that subassembly don't actually need to be mirrored. They can simply be repositioned and reconstrained and reused. And so users today go through a long, tedious effort of manually recreating sub-assemblies to make sure that they are accurately representative of the final parts or the final sub-assembly, and making sure that they're not creating duplicate parts unnecessarily. Consequently, in Creo 4, we're introducing a new intelligent mirror option. This will automatically analyze the sub-assembly you want to mirror, and it will figure out which of those components need to be mirrored and therefore need to be unique new parts, and which of those components can simply be repositioned and reconstrained and therefore reused. In this particular example, out of the 31 components, 8 of those components have been created as new components. The rest of them were simply repositioned, significantly benefiting users in productivity, reduction of time it takes to manually do this operation, but also fostering part reuse, reducing or eliminating the risk of having multiple part numbers that all represent the same physical part. Moving on to Creo Simulate. Here we really have focused on providing better tools to give end users a clearer understanding of what is happening in the simulation process. But not only let them know what is happening, but also provide them guidance as to how to address particular problems that may arise. Again, allowing them to more easily and effectively get their simulation process done rather than spending time trying to self-diagnose the problems. We've also introduced new standard material files thanks to a partnership with Granta. We now have over 100 out-of-the-box material files available to every single user. If your particular material file isn't available, you can go directly to Granta and get the information or get those material files directly from them. In addition to that, continuing on with the flexible modeling theme, we also have now introduced flexible modeling capabilities into Creo Simulate, allowing you to perform your geometry simplification capabilities while you're directly inside Creo Simulate. We've also continued to enhance our mold design capabilities, and one of the main items we've added here is speeding up the process that it takes for engineers to identify geometry that's going to belong in the core and geometry that's going to belong in the cavity for a particular mold. And we've done that by taking into account the pull direction. When we take into account the pull direction, the system can analyze your geometry and automatically from that determine which surfaces are going to live in the core, which surfaces will live in the cavity, and which surfaces need to be created by some slider geometry. It will automatically identify those for you, speeding up the process of you then splitting up your mold tool into those particular components. Working with our partners at ModuleWorks, we're also introducing new capabilities to do full material removal simulation directly inside Creo Parametric. So now you can take all your rich machine toolpaths or complete operations and simulate those, simulate the material removal process for those. This is fully integrated into Creo Parametric. You see it entirely inside the Creo viewport, and it fundamentally gives you a far better understanding and confidence of what the operation is going to leave you with before you start and cut physical metal. Whether you want to simply visualize a single toolpath or a complete operation. And we even provide you the ability to export out individual stock models or in-process stock models based upon a particular operation. Again, giving you more confidence before you physically cut metal. Moving on to our augmented reality capabilities. Wouldn't it be great if you were able to visualize your design that you're working on life-size next to you in your room? Imagine trying to design this motorbike on a 15-inch or 24-inch screen. I don't really have a good sense of size or context. But if I could visualize that motorbike next to me in all its glory, in full size and scale, that gives me a better understanding and a better appreciation of the overall design. With Creo 4.0, we're going to be introducing this capability, leveraging Vuforia technology, the leading AR platform that PTC itself owns. We're going to be integrating that capability into Creo 4, allowing every user to be able to publish an AR experience directly out of Creo. When you've got that AR experience, you'll then be able to view it using ThingWorx View on your iPad or iPhone. But you'll also be able to then share that with your colleagues so they can review your design as well and give you feedback. So this is just the beginning of activities that we're working on for how engineers themselves can benefit from AR and VR to improve their overall process. We're researching many, many different techniques, and you'll see more of this coming out in the future. But in this new world of smart connected products, how can engineers really benefit and how can engineers get clearer insight into how their products are being used? And this is where design for connectivity fits in. Now, in today's world, as a designer, I'm responsible for the digital prototype, the image on the left. I basically design a full CAD model of my product. But once that product goes out into the field and starts getting used, I no longer have anything to do with it. I no longer hear anything back from it. I have no idea of how it's being used, at least until there's a product failure, at which point I have an irate customer on the phone complaining about that my product has failed. But if, as a company, I have a strategy to instrument that product, to put sensors on that product, and I put equivalent sensors inside my CAD tool, inside Creo, and I connect the two through ThingWorx, that gives us the start of what we call the digital twin. The digital twin being a digital representation of a unique occurrence of a product in the field. And this can be used to gain clear insight into how the product is being used, how it's performing, what its current state is, allowing you to make better products for the future and improve your existing products. Let's take a look at a couple of scenarios how that might work. Let's start with a prototype. So let's say, as an engineer today, my task is to design the new front suspension for this racing car. So what am I going to do? I'm going to design the suspension in Creo. I'm going to prototype the suspension. I'm going to put it on a car, and I'm going to get a driver to go out around a track and come back and give me feedback. And he's going to come back and he's going to tell me it was a bit loose in this corner, it was a bit tight in that corner. And as an engineer, my task is then to interpret what that means and how can I improve and optimize the suspension to address that. If, however, I've got sensors on that suspension and I put the equivalent sensors on my CAD model, and I then capture the information from the driver going around the track, not just at one point in time, but an entire sequence of driving around the track. That allows me to then reproduce the entire journey, the entire track in my CAD system, understanding exactly how the suspension is being used, interpreting and understanding the exact forces and loads that are being applied on my suspension, giving me clearer insight into how it's being used, and allowing me then to optimize my design to meet those actual use cases. Another scenario here may be that I've got a product in the field and it has failed. If I have all the sensor readings from that product at its point of failure, I can then feed that information into my CAD system, and I can then understand exactly how it failed. I can understand the true root cause of the failure. And that may not be that the part itself failed, needs to be changed. Maybe it identifies some other part that has exceeded a limit which has resulted in this failure. But again, giving me clear insight, allowing me to make more informed decisions and getting down to the real root cause of the problem. Now, what we talked about there was what we call a one-to-one connection. I've got a connection between my CAD model and a single product out there in the field, whether it be actually out in the field or whether it be a prototype. But there's another scenario, which is maybe I need to design a new product. And when I start designing a new product, I typically start with requirements. And where do those requirements come from? Well, some of them come from historic knowledge. I've been designing this type of product for the last 20 years. I've got a good sense of what the overall requirements are. But a lot of them come from assumptions. I assume this product is going to work in this environment under these conditions. The problem is, if my assumptions are wrong, then my design is either going to be over-engineered or under-engineered. Either way, it's going to cost my business money. But if I've got similar products out there in the field, not just one, but hundreds or thousands of products, and I'm able to capture the usage information from those products, I'm able to analyze that usage information. From there, I can capture the full, actual, true working envelope and use cases for my design. And that, again, can give me clearer insight into design decisions that I might make. It gives me clearer insight into business decisions I might make. I may choose, for example, not to build one product, but build two to address two different markets. Or I may choose to just design one product, and I now have the actual working envelope or working requirements for that product. Now, coming in summer of next year, we're going to be introducing a new Creo Product Insight extension that in essence is going to provide all the capability I just talked about. It's going to enable you to place sensors inside your CAD model. It will enable you to connect those sensors through ThingWorx to actual sensors in the field, allowing you to reproduce your product's behavior inside your CAD system, allowing you to then analyze your model based upon real-world scenarios, allowing you to optimize your model. But also, it will allow you up front to be able to make sure that you're designing in the actual data streams that you want to be getting from your product when it does go into the field. We hear stories from a lot of customers about how they put sensors on their products, but they never really took the time up front to understand the information, the data streams they would get back from the product. So now they're in a situation where they've got thousands and thousands and thousands of data points coming back, too many for them to be able to understand and interpret. And that data gets lost and is then not used. But if up front, before I've built a product, I'm able to simulate the placement of sensors, I'm able to optimize the correct choice and quantity of sensors, and simulate by running my Creo model the actual data streams that I would get from the physical product. Again, that gives me a more informed decisions. It allows me to more accurately get or design towards the data streams that I need. So finally, moving on to additive manufacturing. So additive manufacturing or 3D printing has been around for 20, 30 plus years. Customers have been using 3D printing for rapid prototyping. But 3D printing really came of interest to us a number of years ago or a couple of years ago, when customers approached us because they wanted to use 3D printing for final part production. And this opened up a series of challenges to them. Today, they go through a process of they start with their model inside Creo. They then want to do some optimization of that model. They want to reduce the weight of that model. So they'll go through a process of building lattice structures or topology optimization. But to do that, they need to go through separate software. So they need to export it, bring it into separate software, run the optimization. When they've got the optimized shape, they then need to run it through 3D print check software to make sure that it can be printed, that there aren't holes in it too small or there aren't walls too thin. And only at that stage can they then send it to a 3D printer. But this is not a prototype part. This is a final production part. So they want and need to be able to revision control this. They need to be able to manage this. They want to be able to leverage this inside their existing CAD system. They want to be able to run mass property calculations on it. They want to be able to run kinematic studies on it in the context of the rest of their design. And maybe they even want to build other components around it. So consequently, they go through a second iteration where they then take the optimized design, they bring it back into Creo, and they completely rebuild the geometry to match the optimized shape. Once they've rebuilt that, they then go and run it through some simulation software to make sure that it still meets the design requirements. And only then do they then need to run it through the print check software again. And at this stage, they now have a model that has been optimized, that can be used in their CAD system, that can be used to run kinematic studies or build other geometry off, that has been print checked, can be released to manufacture, tracked and revision controlled. Now that's a very, very time-consuming process. Now obviously if there's a design change, you're right back to the beginning as well. Now that process has leveraged at least 3 different disconnected file formats and leveraged at least 4 different disconnected software packages. Again, a painful process. Now at PTC we don't see the process looking like this. We have a strategy to see the process looking more like this, where you're able to design, optimize, validate, and 3D print check without needing to leave your CAD system or needing to leave Creo. Now we started down this journey in Creo 3, working with our partners at Stratasys by addressing the back end of the process, allowing you to do your print checks directly inside Creo, allowing you to directly connect to Stratasys Connex 3D printers, understand material usage and build time. And in Creo 4, we're expanding that to also support 3D systems printers as well. But Creo 4 really sees us focus on addressing the design, optimize, and validate piece of the puzzle. If you're into additive manufacturing, you're probably into lattice structures as well. 2.5D lattice structures. In Creo 4, you're going to have a dedicated feature, dedicated lattice feature, that is going to allow you to build these 2.5D lattice structures. In this simple example, I'm working on a mold tool. I want to lighten the back of this mold tool and stiffen it up. And I'm going to do that by adding a 2.5D lattice. Again, adding the lattice feature, I have full control over the size, shape, and orientation of the individual lattice unit. And then the system will automatically populate the volume forming with the lattices, even allowing me to add drain holes in if I desire. But that's 2.5D lattices. What about 3D lattices? Again, that same feature will allow me to also build 3D lattices. In this example, I'm looking at a cross-section of a part. Again, I'm going to specify the void I want to fill. I have control over the size, shape, and orientation of my individual lattice unit. And then the system will automatically populate that area for me, or that volume for me, with those lattices. giving me a fully editable control mesh, fully editable lattice structure. But we didn't stop there. In this example, I'm going to, a simple example showing 2.5D lattices again. I start with a bracket that weighs 6 kilograms. I'm going to scoop the inside out and populate it with a 2.5D lattice. Once this is done, because of the tight integration between Creo Parametric and Creo Simulation, our simulation tool, we can now directly go in and analyze it. I can apply my loads, I can apply my constraints, I can run my analysis. We've even sped up the analysis process by allowing you to represent the lattice structures as idealized elements. But in this case, we realize that the yield stress is well below, or the maximum stress is well below the yield stress of the material, so I can do better. Again, because of the tight integration between Creo Parametric and Creo Simulate, I can run an optimization. Because the lattices are features, I have all the parameters that control it. I can tell the system to modify the lattice structure to meet my particular engineering goals. In this case, the optimized lattice is on the left, the original lattice on the right. And in this scenario, we've been able to go from 6 kilograms down to 3.2 kilograms by adding a lattice and then optimizing the lattice. But if I'm trying to optimize lattices, a uniform lattice isn't always going to provide me with the optimal answer. So we are also providing the capability to build variable lattices. In this case, you can see how the lattice is varying in size from the right to the left, allowing you to really build in the engineering responses you want into your design. Which leads me into the next piece. What lattice structures offer is really a new way to think about design. I think this has the possibility to really change the way you think about design, change the type of designs that you go and solve by allowing you to really design in the engineering responses that you need. And let me demonstrate this with a fairly academic example to begin with. Let's say I have a design challenge, and let's say my challenge is to build a new beam. And this beam has certain requirements. It needs to withstand a certain load, and that load is going to be applied at a particular angle. The result of that load is that I want a certain deflection in the X direction. I maybe want a different deflection in the Y direction. Maybe I want to avoid certain resonant frequencies in the beam. I want a single engineer to be able to go and install this beam, so I want it to be as lightweight as possible. And maybe add to that that the external shape of the beam, I can't alter. It was designed by an architect, and so I can't change it. How would I go about solving all of these engineering requirements today? Well, I'm probably not going to be able to do it with a single part. I'm probably going to have to come up with some internal support structure and then clad it in some lightweight material. Or I could put a lattice inside. I could 3D print it with an internal lattice and a variable lattice and change and optimize the variability of the lattice to meet those engineering goals. Now that was an academic example, but what about a real world scenario? Let's take a motorbike swing arm here and let's look at the requirements we have for this. So in this case, we've got a certain load that it needs to withstand, the load from the bike, the load from the rider on the bike. Now I want, in the direction perpendicular to suspension travel, there to be some deflection in my swing arm, because as the bike tilts going around the corner, the swing arm actually acts as the suspension component. In the direction of suspension travel, I don't want any deflection because I want the shock absorber to do all the work. I want to avoid certain resonant frequencies. I want to avoid the chatter from the rear wheel going around the track. It's a race bike. I want it to be as lightweight as possible. And again, maybe the external shape is either penned by a designer, or if it's a race bike, maybe it's controlled by the governing body. Either way, I can't change it. I'm going to add into it that today these are created by building multiple aluminum castings that are then machined and welded together. A very time-consuming, expensive, and iterative process. Alternatively, they can scoop the insides out and fill them with a lattice structure, a variable lattice structure, and then optimize the variability and the size and shape of that lattice structure to meet not one, but all of those engineering goals that they have. Well, I believe this is really going to change the way designers think about solving their engineering problems, the type of engineering problems they can address, and the way they solve them, as well as the speed that they're able to solve them. And this is only possible in Creo 4 with variable lattices, working in conjunction with Creo Simulate and our rich optimization tools. So hopefully that has given you a good high-level overview at some of the exciting new capabilities coming in Creo 4 or available in Creo 4. I believe Creo 4 to be one of the biggest releases, if not the biggest release we've ever done since I've been at PTC. I am amazed and inspired on a daily basis with what it can actually do. The journey begins, or the journey has begun today, December 15th. As of right now, Creo 4 is launched, is available. It will be going up on the download site today, so you will all be able to go and download it, install it, and play with it. So hopefully, thank you for your time to begin with. We've got maybe 10 minutes left. I hope that's given you a good overview, and I'm open to any particular questions that you may have.
So I got one question here, Paul, that says, what about the file name limit?
The file name limit.
The 32 character file name limit. Does that has changed?
Okay. Yeah. So overall, that hasn't been addressed yet in Creo 4. We've done some work in certain areas to address it. So it's addressed regarding our Unite capability, for example. So bringing data in from other systems that have longer file names. But for generally creating parts, you still have that restriction, as well as the restriction of special characters. So spaces and things like that can't be put in. It is something that we are looking to do. We haven't quite got there yet.
And then the next question here is, how about front and back compatibility between versions?
Front and back compatible. So everything is always upward compatible. Like everything that you create in Creo 3 you can directly load into Creo 4 without any problems. Going backwards is not possible. And that is something that at the moment we have no plans to offer. I don't even know how we would offer it. What would happen with the existing or new capabilities that we add, how would those be represented in the old version? Now, having said that, we do have a plugin to Creo called GCRI that does allow you to open up new models inside older versions of Creo, but it brings them in as read-only models, let's say, so you can't edit the features that are there, but you can bring them in, look at them, and maybe even add new features to them.
Okay, and it says, what about support for Android devices? I know Apple, iPad, iPhone are supported in the mobile devices.
So I assume by that you're referring or they're referring to the ThingWorks View product for viewing your AR experience. I don't have a direct answer for that right now. I believe we're working on it, but I don't have a timeline for it.
And let's see, there seems to be one more. In welding, does the solid represent the different types of welds?
Yes. So the weld itself, the solid weld, we can build fillet welds, butt welds, spot welds. Obviously, each weld has a different set of parameters to control it. Again, any weld, we haven't added new weld types. So all the existing weld types that we have are still supported, but they're now supported building solid geometry versus surface geometry that we did beforehand.
Good. I think that's all we have, Paul. So I would like to thank everyone for attending, and to you, Paul, for taking the time to show us this big launch of Creo 4.0 and all the the high-level overview. Now, hold on, because I do have one more question here. Is in the new mirroring feature, how does it recognize which components need to be mirrored?
So that's the analysis that the system does. So you specify the subassembly you want to mirror, you specify the plane you want to mirror it about. The system is then going to go and analyze all the geometry and figure out, is this part naturally symmetrical, right? If the part is symmetrical, then it can be repurposed on the other side. If it's not symmetrical, then it's going to need to be recreated. So the system automatically analyzes each and every component for you to do that.
Okay. And then there's one more here. Is the weld symbol node now configurable to suit internal process?
I don't have an explicit answer for that. We did do changes to weld nodes. I believe we have made them configurable, but I couldn't say for sure. I would need to dig into that one.
Okay. Very good. So that does seem to be all we got, Paul. So again, thanks for your time, and thanks everyone for attending. Good luck in the laptop giveaway. Again, the winner will be announced tomorrow. So again, thanks everyone for attending.
Thank you very much for your time.